Hello everyone, welcome back to my channel. My name is Sanjeev Garg. So today we will be discussing the next problem in our dynamic programming series, that is minimum sum path. Okay, this question is just similar to the previous question. In previous question what we were doing, we were trying to find the unique paths from the source to the destination, or from the upper left corner to the bottom right corner. Now we have to find the minimum sum path, basically from the upper left corner to the bottom right corner. Okay, let's first read the problem. Okay, Ninja World is a country in the shape of the two-dimension grid. Okay, and rows and the m columns. Each point in the grid has a some cost associated with it. Find a path from the top to the left to the bottom to the right. Okay, so let's see the example. If you see this example, 596 so minimum path that it followed is 00011112, that is 5 plus 9 plus 5 plus 2. Okay, that is 21 only. So let's understand this problem first. Okay, let's understand this one. So minimum unique path. Okay, so the problem is, let's say we have a 2D array. We have this 1 here, 2 here, 3 here and 4 here. So minimum path from reach from the source to destination. Let's say my robot is at here and I need to reach at here. So there are two paths here. I can go to the right and I can go to the down. I can go to the down, I can go to the right. Okay, in the one path the cost is 1 plus 2 plus 4, and in another path 1 plus 3 plus 4. This one is 4 plus 2 6 and 7, this is 8. So minimum path is this one. So our answer should be minimum cost path is this one. So answer should be 7 only. Okay, so this is the question that we have to find the minimum path. If you see, at each cell, let's say if there is a 3D array, let's say 3D array, sorry, let's say 3 cross 3 array. Sorry. Okay, let's say I am at this cell. Okay, so I have to find the minimum cost to reach at this cell. So what it will ask to its left side, it will ask to its upper side, hey, how many minimum costs are reach at you, how many minimum costs at reach at you. So let's say if it says to reach at me is 10, it says to reach at me is 20, and cost of this cell is, let's say, 5. Okay, so what this cell will do, this cell will calculate 5 plus minimum of both these twos. Minimum of both these two means minimum of 10 and 20. So 5 plus 10, that will come to the 15 only. So earlier what we were doing, it will return the total number of the unique paths. So answer will be 20 plus 10. In the previous question it was, but in this question we have to find the minimum cost path, that from the upper left corner to the bottom right corner. Okay, so similarly the time complexity will be 2 raised to power mn, and if I'll talk about the time complexity, this is same as we did in the previous question. Time complexity is same as 2 raised to power m, and space complexity will be the total number of the depth that we are going is m plus n. And we can solve this problem with the help of memoization. In the memoization we will take a dp array. After that we will go with the tabulation. We will go with the tabulation, and after that is the space optimization. Okay, all these things we have already done in my previous video, so highly recommend you to watch my previous video so that you will get better understanding of these concepts about the memoization, tabulation and the space optimization for this question as well. So let's get start with the coding, how we are going to solve this with the help of the coding, as we have already done in previous example. So if you have watched my previous videos, so you will definitely get better understanding for this question as well. Okay, let's get start with the coding. So let's start with coding. Okay, so we will do the same thing that we have already done in our previous questions. Okay, so if you have not watched my previous video, so highly recommend you to watch that videos. Okay, util, we will simply, here we will find the row int m equal to grid dot length. Okay, so to find the column, let's see the first row, and in first row how many columns are there. Now we will simply return util function, and here we will return m row and column and grid. Okay, so we are taking the index from 0 to m minus 1 and 0 to n minus 1. Okay, so here int m, int n. Now first is base case. If my m is double equal to 0 and my n is double equal to 0, okay, it means I am at the 0 row 0 column. Means let's say if there is only one cell, and how many ways we can reach. Okay, so we have to find, here is the minimum path sum. So we will return simply, in previous question we have written 1 is the total number of the ways, but in this we have to return the minimum path sum. Let's say if there is only one cell, then we will return only value of that grid only, because there is no other way. Okay, so m and n. Now we'll find the up equal to int left equal to. Okay, so to find the up, so our row will reduce by 1 and column will remain same, and this is our grid. Okay, to find the left, our row will remain same, column will reduce by 1, and this is our grid. Okay, so we have to return we have to return the minimum path sum. So how can we return the minimum path sum? Math dot minimum of up and left. So if I'm at position I and j, I'll ask to up and left, hey, what are the minimum path sum to reach at u? So they will give, and I will add my sum in this. I will add the grid sum where I am right now. So m, grid of m and grid of n. Okay, so up m minus 1, n minus 1. If our m is less than 0 or n is less than 0, what we are going to do, we will simply return, because we have to find the minimum sum. Let's take the maximum value, integer dot max value. Okay, let's run this. Let's run this. Okay, it's taking time. I think we should refresh the page. Let's refresh the page and let's run again. Okay, yes, now it's running. Okay, let's try to submit the code. Okay, so compilation check is working. Largest test cases it will check. Okay, so it's taking too much time limit exceeded. So now what we will do, we use the memoization int dp equal to new int. Okay, so this is m, this is n. Now we will pass dp to all the function in the next step. Okay, so we will here we pass dp int dp, and below also dp here and dp here, and before recalculating it again and returning it. Okay, so we will save this, and before recalculating it, we will check whether dp of our row and column is not equal to -1. What we'll simply do, return dp of m and n. Okay, so we have to find the minimum value. So what we can do, we can take the integer dot max value here. Okay, so we will fill this dp for int I equal to 0, I is less than row I plus plus arrays dot fill dp of I with integer dot max value. Okay, so now we are checking this one. This is done. dp we have passed. Let's run this. Okay, let's try to submit this. Okay, so we are able to submit this. Now again what we have to do, we will do tabulation approach. So we don't need this. For just simply we will run the loop int I equal to 0, I is less than row and I is less than I is I plus plus. Okay, for column for int I int j equal to 0, j is less than and j plus plus. Okay, so our first base case is if I is double equal to 0 and j is double equal to 0, what we will do, we will simply put dp of ij equal to grid of ij, and we will do continue. Okay, there is no need to go down. Now if we are not at the 0 position, so we will calculate up. Int up equal to 0, int left equal to 0. Okay, so up will be dp of I minus 1, because we are doing up means row is decreasing by 1 and column will remain same. And okay, so if we need to check if negative case, if I is greater than 0, similarly for if j is greater than 0, we'll simply check left equal to dp of I and j minus 1, j minus 1. Now dp of ij is equal to our grid value, grid of ij plus math dot minimum of up and math dot minimum of up and left. Okay, so minimum, what we have to find the minimum, so what we will do, integer dot max value here, similarly integer dot max value here. Okay, so now no need for this, we can remove this function, and at last we will return dp of m minus 1 and n minus 1. Just remove this. Okay, so ij grid value we have put here, so up, left and I is greater than, let's format this. Let's run this. Okay, large test cases is okay, so we are able to submit it. Now for the space optimizations, what we can do, we can take just simply a previous array as we already did in previous questions. Okay, we'll take a current array. Okay, so to calculate the first row, what we will do, we need a current array, new int okay, so when we are calculating, okay, so dp of I means our current array, we have to put in our current array, and here dp of I minus 1 means our previous array. Similarly here our dp of is I is current array, here dp of I is current array. Okay, this is current of j minus 1, this is previous one. Okay, math dot left, and at last we will return previous of n minus 1. Okay, so previous current, let's run this. Okay, if you see, our current will become previous will become current now. Okay, so previous is equal to current. Okay, so we are able to submit this as well. So this is the way how we can go from the recursion approach to the memoization to the tabulation, and after that the space optimization. Okay, so I think I hope you like this video. If you don't like or like, please comment in this video so that I can make more videos and give the answer to your comments. Thank you.